Assalamu alaikum, this is Tuqa Damush. Today I'll be explaining the third period of chapter 1, Atoms. At the end of this session, you'll be able to identify isotopes and calculate the average mass number of an element. Please get your pen and your chemistry booklet. Have you ever gone through a whole bag of multicolored M&Ms? If you look inside the bag of M&Ms, the shape and the size of each M&M is relatively the same. However, there are different colors, so we can say they are different versions. If we count how many M&Ms there are for each color, sometimes we find that the most popular color in one bag is a brown, and other times it's a green or yellow. Just like M&Ms have different versions, atoms of the element in the periodic table have different versions of each others, called isotopes. So, what are isotopes? In nature, carbon exists in three different forms: carbon of mass number 12, carbon of mass number 13, and carbon of mass number 14. Can you determine the nuclear composition of each carbon atom? Let's start with carbon of mass number 12. It has 6 protons and 6 neutrons, while carbon of mass number 13 has 6 protons and 7 neutrons. On the other hand, carbon of mass number 14 has 6 protons and 8 neutrons. Now compare the number of protons in carbon 12 to that in carbon 13 and 14. Right, they all have the same number of proton, which is 6. Compare the number of neutrons in carbon 12 to that in carbon 13 and 14. Exactly, the three carbon atoms have different number of neutrons. So, how can we describe the relation between the three forms of carbon atoms? They are isotopes. So isotopes are atoms of the same element having the same number of protons but different number of neutrons. Or we can say that they are atoms of the same element that have the same atomic number Z but different mass number A. Isotopes of an element have different natural abundances, which is the percentage of the isotope that is naturally found on the planet. Let's take as an example carbon element. Carbon of mass number 12 has a percentage abundance of 98.93% and it's a stable isotope. Also, carbon of mass number 13 is a stable isotope too and has a percentage abundance of 1.07%, while carbon of mass number 14 is found naturally in trace amount, which means extremely small amounts, and this isotope is considered to be unstable. Consider the three isotopic forms of magnesium element: magnesium of mass number 24, magnesium of mass number 25, and magnesium of mass number 26. Listen to the question. What's the mass of each magnesium atom in AMU? Pause the video and think of the question. In the previous session, you've learned that the mass of an atom is equal to its mass number but in unit U. So the mass of magnesium 24 is a 24U, and that of magnesium 25, it's a 25U. Similarly for magnesium 26, which is a 26U. A question must cross to our minds. What's the mass of magnesium element? Is it a 24U or 25U or it's a 26? I guess that your answer is the average, which is true. But is this average? If you answer yes, your answer is not wrong, but it's not true as well. This would be possible if the three magnesium atoms have the same percentage abundance. However, this is not the case in magnesium element. The percentage abundance of magnesium 24 is 79%, and that of magnesium 25 is 10%, while the percentage abundance of magnesium 26 is 11. Since the percentage abundance of magnesium 24 is the highest, this isotope will have a significant effect on the average atomic mass. In fact, the average atomic mass of magnesium element is 24.3 AMU, which is nearest to the atomic mass of magnesium 24. So the mass of an element is the average mass of its isotopes. To calculate the average mass of an element, we use the relation mass number of the first isotope multiplied by its percentage abundance plus the mass number of the second isotope multiplied by its percentage abundance, etc. over 100. Remember that the average atomic mass is expressed in AMU. The atomic mass on the periodic table is stated as a decimal number because it's an average of the various isotopes of an element. The atomic mass of iron element is 55.845 AMU, since iron occurs naturally as a mixture of 3 isotopes. Now move to worksheet 2 in your worksheet booklet. Let's solve the first example. The isotopic percentage abundance of oxygen in nature is given in the table below. Calculate the average atomic mass of oxygen element. Perform your calculations using the average mass rule. I'll count down to 10, then I'll be back to correct it. Back to correct the example. The average mass of oxygen is equal to the mass number of the first isotope multiplied by its percentage abundance plus the mass number of the second isotope multiplied by its percentage abundance, etc. over 100. So 16, which is the mass number of the first isotope multiplied by 99.76 plus 17, the mass number of the second isotope multiplied by 0.04 plus 18, which is the mass number of the third isotope multiplied by 0.2 over 100. The answer is 16.004 U. Before closing, let's solve one more application. The isotopic percentage abundance of iron in nature is given in this table. Number 1. Calculate the percentage abundance of iron with unknown mass number. As you know that the sum of the percentages is equal to 100, substitute the percentages of other isotopes. The value of X is equal to 2.5, which corresponds to the percentage abundance of the third isotope. Move to the second part. Determine the mass number A, knowing that the average atomic mass of iron element is 54.967 U. So you will use the average mass relation. In this relation, everything is known except for the mass number A, which corresponds to the mass number of the third isotope. Bring A in terms of the others. A is equal to 56. Finally, it's time to summarize. Isotopes are atoms of the same element, having the same number of protons or atomic number, but different number of neutrons or mass number. The mass of an element is the average mass of its isotopes. The average mass can be calculated using this formula. The average atomic mass is expressed in U or AMU. For the next period, please watch this video again, then solve worksheet 2 in your chemistry booklet. Study well and blessed efforts.